Mr. Speaker, I wish to congratulate Google Quantum AI on an astonishing accomplishment in the field of quantum computing. Its new Willow chip performed a computation that is truly mind-boggling, that is otherworldly, literally otherworldly, according to some. On the performance benchmark known as random circuit sampling, it performed a computation in under 5 minutes that would take one of today's fastest supercomputers 10 to the 25th years. That's 10 septillion years. You can see the number here. 10 followed by 25 zeros years. By the way, that is way longer than the age of the universe. That's how long it would take one of today's fastest supercomputers to perform the calculation that the Willow chip did in 5 minutes. The chip was built in California, in Santa Barbara, as part of Google Quantum AI's goal of, quote, building a useful, large-scale quantum computer that can harness quantum mechanics, the operating system of nature, to benefit society by advancing scientific discovery, developing helpful applications, and tackling some of society's greatest challenges. So how did they do it? Well, the key breakthrough here was something known as exponential quantum error correction. One of the major challenges to making a viable quantum computer has been the issue of errors, which occur when the units of computation, known as qubits, exchange information with their environments, and that contaminates the information that's actually needed for a computation. So the problem with building a quantum computer is that when you add more qubits, you get more errors, and you lose the special quantum quality that can be so powerful if properly harnessed. What's truly amazing about the Willow system is that the opposite has occurred. The more qubits that are used, the fewer errors there are. Indeed, as the grid of qubits scaled up in tests, there was actually an exponential decline in errors. So this breakthrough has brought practical applications of quantum computing with insight. And you know, it's been recognized for some time now that probably the two most world-changing technologies in development right now are AI and quantum computing. But they've sort of been proceeding at a different pace and a different level of visibility. AI is already transforming the world around us. We have hundreds of millions of people around the world using LLM chatbots and other systems. We have AI-powered driverless cars and countless other applications. And you have new releases from the leading labs every day. Indeed, Google released several new offerings just in the last few days when it comes to AI and Gemini, which is its LLM. ChatGPT, or OpenAI, is in the middle of a 12 Days of Christmas, where they do a new release every day. So people can see the progress that's happening with AI before our eyes, whereas the work in quantum computing has been done in labs in Santa Barbara, what they call the coldest place in the world because of the conditions they have to have there to try to make advances and to perform tests. And we haven't yet reached the stage of practical application. But that could be changing soon. And indeed, you could start to see where these two fields, quantum computing and AI, intersect in truly spectacular ways. I was intrigued by the words of Hartmut Nevin, who's the founder of Google Quantum AI and actually worked in AI before. And he was asked why it is that he changed fields. And he said this, he said, "My answer is that both will prove to be the most transformational technologies of our time, but advanced AI will significantly benefit from access to quantum computing," noting that quantum algorithms have fundamental scaling laws on their side, and this allows for the modeling of systems where quantum effects are important. And so some of the applications that he cites are helping us to discover new medicines, designing more efficient batteries, and accelerating progress in fusion and new energy alternatives. So I think that this is important for those of us who are here in Congress making policy, to be mindful of extraordinary developments like this, because we need to be attending not just to the needs of the present, but also thinking about the future. And based on exciting developments like the one Google Quantum AI has just announced, there is every reason to expect that the future may look very different in many ways than it does right now. So it behooves all of us to start thinking about how we prepare for how we start to prepare for it. Thank you, and I yield back.